the PVTn box. Now, the PVTn box will be used for our combined gas law math, or really any of the gas laws, as long as it's not the ideal gas law. Now, when we set up the box, your worksheets in class will set it up this way, PTVN. The order doesn't matter as long as you actually put the numbers in the correct column. Now, we have 3 rows of information, the I, the F, and the C. The I stands for your initial, so those are going to be your starting numbers. The F is the final starting numbers, so the final number is what you end with. And the C is where you're going to show the trend arrows. Now notice this large red sentence. All math temps must be in Kelvin. Have to. If you get a negative answer, it's wrong. So Kelvin equals the degree Celsius plus 273, or even if they ask you for the answer in Celsius, it's okay. Do your math in Kelvin and then change the Kelvin back to Celsius by doing K minus 273. Now, all you need to know to be able to do math this way is these 3 things. If you need to make your number get bigger, it needs to go up. Put the big number on top. If your number needs to get smaller, go down, put the big number on bottom. Label your trend arrows and life will be grand. Now, I have a pretty hard version of one of these questions, and I'm going to walk you through it. And if you can understand this one, you're golden. Now, this is a question from a chemistry textbook. So, let's look at it. Now, remember with word problems, it is very good to label things as you come to them. So, a sample of neon gas at a pressure of 1.08 atm. So, it's at that, so we're going to assume this is a P1. Fills a flask with a volume of, so this will be our first volume, at a temp of 24.0 degrees Celsius. This is our T1. Now, if the gas is transferred to another flask, so this will be our final variables, we have a final temp and a final pressure, and ask what is the volume of the new flask. So we want to know the final. Now, one of the first things you should notice is those temperatures are not in Kelvin. So step 1, change those temperatures to Kelvin. So we take our 24.0 degrees Celsius. We're going to add that to 273. Sorry. Then we're going to take the 37.2 degrees Celsius. Add that to 273 to get our 2 new Kelvin values of, and we get 297 Kelvin and 310.2 Kelvin. So this is our T initial, T final. So then we start filling in all those numbers from the question to our handy dandy PVTn box. Well, mine's not much of a box. We can make it into a box. Now, so our first pressure was 1.08 atm. Our first volume was 250 ml. And we had our first temperature of 297 K. Final temperature was 310.2 K. We do not have a final volume. We want it. And our final pressure was 2.25 atmospheres. At this point, please remember to check your units, because these have to be in Kelvin. And if you have 2 of one number in the same column, it has to have the same unit. So notice both the pressures are in atmospheres, both the temperatures are in Kelvin. You cannot have mixed matched units because we're going to use dimensional analysis. Now, here's where the labeling comes in handy. So if we have 1.08, we go to 2.25, that is an increase. And when pressure increases, pressure is going to make the volume go down. So we always start, so you find your question mark, you write the number above it or below it, depends on what you're doing, 250 milliliters. We're going to do our pressure setup. So the pressure needs to make it go down, so the bigger pressure goes on the bottom. And notice, by putting the pressures above each other, our atmospheres cross out. Next, we look at the temperature. Now, temperature increased. And when temperature increases, the temperature will make the volume increase. Because remember, on our combined gas law, volume and temperature are above each other. So that's okay. So on this conversion, we put the big number on top and the littler number on bottom. So then, put in our calculator. Now we're going to work our way across the problem. So we start with 250. Then we multiply by the 1.08 equals. Then we divide by the bottom. Divide by 2.25 equals. Then we move over here. Times 310.2 equals. Divide by 297 equals. And we started with 250 milliliters, so it's pretty reasonable that by changing stuff, increasing the pressure, and even though we only increased the temperature, we didn't increase it a whole lot. So our new volume is keeping 3 sig figs, since all our given numbers, 3 sig figs, 3 sig figs, 3 sig figs, 3 sig figs, only 2 sig figs. Ooh, we need to keep 2 sig figs, not 3, because this one only has 2. So we will keep our number 2 sig figs, 1, 2, look to the right, so 130 ml. And you're done. Now remember, since we were multiplying and dividing, we based the number of sig figs to keep by our starting value and all the starting numbers up in the problem. The number of sig figs, the least. And that is the hardest. Ooh, in case you wondered, since we had no ends, we were just able to ignore it. And if it makes you feel better, just cross it out.